Okay, the bracket in quantum mechanics. So in quantum mechanics, bracket, and bracket are part of Dirac notation or bracket notation invented by Paul Dirac. They provide a powerful and elegant way to describe quantum states, operation, and measurements. So we have the kit here. This is the psi. It represents a quantum state vector. Think of it as a column vector in a complex vector space, Hilbert space. For example, a spin of one half particle in the up state is written as get up or get zero in qubit notations. So anything inside the kit is a label for the state. For example, psi state here is the kit. So kit zero is the uh, that is the kit, that is the state of the that is the quantum state. So an x equal to 3 kit. Then we have for the bra. The bra represents the dual vector conjugate transpose of a kit. Think of it as a row vector with complex conjugated interest. It is the Hermitian conjugate of a kit, that is this bra of phi is equal to the Hermitian conjugate of this kit phi. So used to act on a kit to produce a number via inner product. So we have the bracket here. So it represents the inner product between two states vector. So it is a complex number, probability, amplitude. Basically, this represent is the amplitude. The bracket is the amplitude of the system in the state psi here to be found in the state phi. The probability here is equal to the bracket, the square of the bracket here of the absolute value of the absolute value of the phi bracket phi and bracket phi on bracket phi of bracket phi and get of the psi here. So we have example here. If the get psi here is equal to AB, and the get of the phi here is equal to C and D into the complex space. So the bra here is C asterisk and D asterisk. This is the conjugate transpose. So the bracket here is C asterisk times the A and plus the asterisk times B. So this is scalar. So we have the key connections here, notations. So we have the vector column here. This represents the get, and the bra here, the dual vector. This is the conjugate. So that is the row vector. We have the inner product here of the bracket of the phi and psi here. And we have the outer product here. It's the symbol for the outer product, operator matrix. We have the expectation value of operator A here. So why the name Sabra and Kit? And Kit. Dirac split the word bracket. Bra plus Kit. So this is the bracket. So physical intuition, Kit the state of the system before a measurement here. Bra the effect of measurement, uh, projection onto a specific state. Then we have the bracket, the probability, amplitude linking to states here. For example, here, so this is called zero. Orthogonal states cannot be in both at once. So we have the zero equal to 1, the bracket. So this is a normalized states. So we have examples here. We have the kit a column. So we have the phi here of the uh, phi as the uh, column vector. This means the system is in a superposition. So probability to be in a basis state. So 0, 0.6 squared equal to 0.36. probability to be in a state 1, 0.8 equal to point 0.8 squared 0.64. So note that this phi, the kit of phi is defined as the column vector 1, 0. Then for the bra here is arrow vector conjugate transpose. For example, here the kit of phi here exactly basis the state here. So it's bra is the conjugate transpose. So 1, 0 since numbers are real. So we have the same transpose here. So if the numbers were complex, the bra would include the complex conjugate. So we have the complex conjugate of I and tau here. So the complex conjugate is negative I and tau. So the bracket here is, this is the inner product, this is the amplitude. So the real number sample, take the kit of this phi here, 0.6, 0.8. This is the column vector of phi here. So that is equal to, and we have another vector given here. This is the uh, so we have the, this is one is the phi here. This is psi, this is phi. Phi is 1, 0, this is the column vector. So we have the bra of the phi here is 1, 0. This is the row vector. So the bracket here is 1, 0. We have the 0.6, 0.8 here. So the product is 1 times 0.6, 0 times 0.8 equal to zero point 0.6. So the physical meaning, amplitude to find the system in the state get of the phi here. So this is equal to zero point 0.6. Probability is 0.6 squared equal to 0.36. So we have the complex number example. So we have another example here. The phi, psi of psi here is 2 plus 3i. This is uh, the matrix here. This is the column vector 2 plus 3i, then 1 minus I. We have the uh, another example here. We have the phi here. Phi, the column vector is 1 and 2i. So bra of phi here conjugate of the column vector and transpose is 1 minus 2i here. Now compute the bracket. So we have the bracket here. So we multiply this by this. We multiply this row vector by this column vector here. So the answer here is equal to I. So by using the same procedure here, how do we how we multiply the two matrices here? So the product here is equal to I. So we have the result here equal to I. So the probability here is I squared equal to 1, so certainty, which makes sense if the psi and phi are actually the same. So normalized state up to a global space, but in this case, it's just coincidental. So we have the physical interpretation of the psi here, the quantum state of a system. So we have the physical meaning, represents the complete physical state of a system at a given time. So it encodes everything that can be known about the system: position, momentum, spin, and energy. So in the lab, a kit corresponds to a preparation procedure. Spin one half particle, so polarized along Z or an electron with energy is of zero. So we have the analogy here. A classical state vector like a point in space, space, but in complex Hilbert space here. So we have the bra, the effect of measurement or projection. So physical meaning represent a measurement that as is the system and the uh, state phi. More precisely, it is a linear functional that, when applied to a kite psi, gives the amplitude for finding the system in phi here. So it also serves as the dual of a kit, the conjugate transpose of the corresponding to state vector. In an experiment, the bra here corresponds to preparing a detector to measure whether the system is in the state phi here. So, okay, idea, you cannot physically prepare a bra alone. You always act on a kit to give a meaningful number amplitude. So we have the bracket here, the probability amplitude overlap between two states. So physical meaning, the complex number was squared magnitude gives the probability that a system prepared in the state psi will be found in the state phi here upon measurement. It also so the quantifies the overlap or similarity between two quantum states. So we have the special cases. This one is one. The system is normalized. Total probability is equal to one. Now this one equal to zero. The states are orthogonal, perfectly distinguishable. So if the system is in psi, state psi, it will never be found in the state phi here. So we have the physical process. So this one, the preparation, time evolutions, maybe measurement with outcome here for the phi. So we have the probability equal to the square of the absolute value of the bracket of phi and psi here. So we have the summary of the table. So this one, the state of a system, what it is, interpretation. Then we have the bra here, the measurement of prediction and to state what you should ask, what you ask. Then this one, the amplitude for transitioning from get psi to uh, get phi here, how likely. So one sentence, the kit is the state, the bra is the question, and the bracket is the answer. A complex number giving probability. So we have example here. So we have the kit here. So by verification, so we have the kit at 0.24 and 0.57i. We have here negative 0.24, negative 57i, and 0.25 plus 0.47i. So we have here 0.25 plus 0.47i. We have the kit here. So the kit here is negative 0.24. So the kit here is, so we have the kit here is 1.09 and negative 0.81 I here and 0.67. So we have here 0.67 and plus 0.33 here I. So we have the bracket here negative 0.7109 minus 0.0295 here. So this is the answer. Negative. That is negative 0.7109 here and negative 0.0295 here I. We have the probability here. Amplitude is negative. This is always positive, 0.506249. So this is 0.506249. We can also differ the value of uh, the value of the A real value of A and the imaginary value of A, and the real value of B and imaginary value of B. So, for example, here we have a different value for B real and B imaginary here. So, for example, here our kit here is negative 0.44 and 0.03. So negative. So we have it here is negative point 44, negative 0.44, and negative 0.03i. So kit here is negative 0.44, negative 0.03i, negative 0.03i, and negative 0.43, negative 0.43, and 0.16i. And for our bra here, negative 0.24 and negative 0.57i here. And we have also 0.25 here and 0.47i. So what is our bracket here? So the bracket here is uh, negative 0.0942. So we have negative 0.0942 here and positive 0.0959i. So we have 0.0959i. Then what is the probability here? 0.080705. So we have here positive 0.80, positive 0.1807, this one. So we have the correct verifications.